Next test is aggregation, and this part's probably the trickiest part of the whole set of protocols. What we're doing is classifying the aggregates that we find in the soil, and we want to be using the NRCS classifications for aggregates, so you can actually find a full description on soil aggregation in a field book called the Field Book for Describing and Sampling Soils, which is put out by NRCS. You can find that on their website. We have sort of a simplified version of their categories in the protocols just to make it a little easier for you, but if you wanted the expanded version of it, you can use their original resource. But what you do is you create a slice of your soil and you place it in front of you to look at. And what we do in our protocols is we classify the aggregates in the top 4 inches, 4 to 8, and 8 to 12. And so I've actually compressed them just a little bit here, just to make it a little easier to see. So we want to be looking at the aggregation at 3 different levels, 0 to 4, 4 to 8, and 8 to 12. So this is 0 to 4. You can see here that there's a lot of really nice aggregation. I would call this granular aggregation, and this is fine to medium size. And for a full description of those distinctions and those different categories, you can look at our manual, which we're providing a link to with this video. But these are granular aggregates because they're relatively circular, and the size classification is fine to medium, which has to do with the number of millimeters of diameter the little aggregates have. But the other aspect is prevalence. So prevalence is the relative preponderance of the aggregates compared to either solid compacted soil or loose playground sand, kind of like falls through your fingers, not aggregated soil or unaggregated soil. So this is, I would call this a strong prevalence. We usually grade weak, moderate, or strong, and this is definitely strong because I'm seeing basically no unaggregated soil here. Oh, here's a nice macro aggregate. Oof, that's beautiful. It's got some vetch nodules in there, rhizobacteria in there. But yeah, you can see that as you break apart the macro aggregate, it just breaks apart into smaller aggregates. So that's a strong prevalence. For the middle profile, 4 to 8 inches, we have, you can see that we have actually more what looks like coarse, blocky aggregates. Granular aggregates are considered higher soil health. These are larger, but they're not as separately aggregated, and they are, as you break them apart, they're kind of not falling apart into this cottage cheese kind of appearance, but they're a little bit more chunky. Still I would call these aggregates and not kind of clods because they have good porosity, and they're nice and dark in color, and there's roots moving through them, and there's little pores in them. But as we move deeper and we start to get into some of the subsoil, if you were to find just chunks of soil that are hard, like rocks, and are very smooth on the edges, don't have good porosity, you're starting to get into what is just massive soil or just clods of soil that aren't really aggregated. But this is still kind of in the realm of what we would call aggregated soil, but there's no real bright line between those categories of clod and aggregate. It's a little bit subjective. I've had many conversations with my state NRCS soil scientists to sort of help try to define these things, and really it's just a matter of exploring, and it's a little bit subjective, but this is still really nicely, has a lot of surface area, and it's sort of, it's in the realm of cloddy because there's less roots going through it, the color is lighter, and it's blocky. But as we head down into the soil profile, we're looking at a weaker aggregation, blockier. Up here we have granular and strong prevalence, and as we go down, we're finding weaker prevalence and blockier structure.